Hello everyone, and welcome back to the Software Engineering Pathway. I'm Sam, and today we are moving from the planning phase to the execution phase. We are diving into Skill 19, S19, implement software engineering projects using appropriate software engineering methods, approaches and techniques. In our previous sessions, we acted as architects and planners. Today, we are the master builders. S19 is about taking that perfectly designed plan and turning it into a living, breathing software system. The concept I want you to hold on to is precision. A master builder doesn't just stack bricks randomly. They follow the plan with discipline, ensuring every joint is strong and every line is straight. Our goal is to prove that you can not only design a solution but also build it to a professional standard. Because in this industry, ideas are cheap, implementation is where the real value lies. Let's decode the standard. S19 asks you to implement. But the crucial part is the end of the sentence, using appropriate methods. This means we are not just hacking. Hacking is writing random code until it accidentally works. That is not engineering. Engineering is structured. It uses design patterns. It follows coding standards. It uses version control properly. Your key insight for today is that how you write the code matters just as much as what the code does. Clean code that another human can read and maintain is far superior to clever code that only you understand. We are building for the future, not just for today. The first pillar of implementation is clean code. This is the foundation. If your code isn't readable, it isn't finished. We focus on naming. A variable named D is useless. A variable named days overdue tells a story. We focus on functions. They should be small and do one thing only. If your function is 100 lines long, refactor it. We use comments sparingly. Code should explain what is happening. Comments should explain why you did it that way. To help us, we use Linters, tools that automatically yell at us if we break these rules. Using a linter is a key S19 technique. The second pillar is design patterns. These are the proven templates of our industry. Instead of inventing a new way to create objects, use a factory pattern. If you need to connect a new system to an old legacy system, don't write spaghetti code, use an adapter pattern. If you need to update the UI when data changes, use the observer pattern. Why do we use them? Because they make your code predictable. When another engineer sees use a factory, they immediately know what the class does. It creates a shared language. The third pillar is version control discipline. Implementing software isn't just typing, it's saving your work safely. We use atomic commits. Don't work for 3 days and do one massive commit called work. Commit every hour. Fix, login bug, feat, add button. We use feature branches. Never commit directly to the main branch. Work in safety on your own branch. And we use pull requests. This is the professional way to merge code. It invites review and ensures quality. This discipline creates a history. If something breaks next week, we can look back and see exactly what changed and why. Finally, integration and deployment. Code on your laptop provides zero value to the business. S19 is about getting it live. This involves integration, connecting your code to the real database and external API. It involves using CI/CD pipelines to automate the build process so it's repeatable. And it involves managing environment configurations. You never hardcode passwords. You use .env files or secrets managers to handle configuration safely. Remember, it works on my machine is not a valid implementation. It must work in the production environment. How does S19 apply to your specific role? If you are Frontend, you are implementing components. You might use the container presentational pattern to separate logic from visuals. If you are Backend, you are implementing API endpoints. You are writing the validation logic and the error handling to ensure the server doesn't crash. If you are full stack, you are the bridge. You are handling the data flow between the two, managing things like CORS headers and JSON parsing. And if you work on legacy systems, your implementation might be refactoring, taking a giant, messy class and breaking it down into small, clean microservices. Here is how you can apply S19 tomorrow. Action 1. Clean code. Look at the code you wrote yesterday. Be honest. Is it clear? Rename one variable to be more descriptive. Find a long function and break it into 2 smaller ones. Action 2. Pattern. Look for an opportunity to use a design pattern. Do you have a database connection? Make sure it's a singleton so you don't open 100 connections. Action 3. Get discipline. For your next task, force yourself to use a feature branch. Make 5 small, descriptive commits instead of one big one. Open a formal pull request. The goal is to practice the discipline of engineering, not just the typing. For your portfolio, use STAR. Show the how. Situation: I needed to implement a critical data import feature for the new analytics dashboard. Task: I had to ensure the code was maintainable, scalable, and could handle large file uploads efficiently. Action: I implemented the solution using Python. I applied the strategy design pattern to create a flexible system that could handle CSV, JSON, or XML files easily. I enforced code quality by using a linter, Flake 8, and adhered to our team's strict Git flow branching strategy. Result: the feature was deployed successfully and can process 1 GB files in under 10 seconds. Reflection: I learned that using established patterns like strategy significantly reduced the complexity of the code and made it easier to test. In your major project, S19 is your implementation chapter. This will likely be your biggest chapter. You must include code snippets. But don't just paste 1,000 lines. Pick your highlight reel. Show the smartest, most interesting parts. Annotate them. Draw boxes around the design pattern you used. Add arrows pointing to the error handling logic. Explain why you wrote it that way. I used a factory pattern here to allow for future expansion. Include screenshots of your IDE and your Git history to prove you did the work professionally. Let's wrap up. We've learned that S19 is about being a master implementer. We built on the pillars of clean code, design patterns, version control, and integration. We learned that precision and quality are what separate engineers from hackers. Your next step is to find a piece of code you wrote 6 months ago. Refactor it. Apply a pattern. Make it cleaner. In our next session, we will look at S20, where we deal with reality, what happens when the requirements change halfway through. We learn to be agile. Remember, code is read much more often than it is written. Write for the reader, not just the compiler. See you next time. Thank you so much for joining me today. I hope you now feel more confident in mastering this topic. If you found value in this session, I have a small favor to ask. Please hit that subscribe button, give this video a like, and follow our channel. It really means a lot to me and helps the algorithm show these lessons to other apprentices, just like you, who need support. Don't forget, you can download today's slides and the full transcript at www.mentorinai.com EPA Hub. While you are there, check out our mock interview and portfolio review services to make sure you are fully ready for your EPA. See you in the next video. Keep learning.